Okay, so we're doing this for the first time, so we're figuring out if the technology is working, so bear with us while we make that work. I hope there's somebody there who hears me rambling about the tech here, but my little app says that we are live, and I hope there are people watching it. So we are just going to proceed as if we are working. So I will start with the introduction. I hope everybody can see this here. So I will start with the introductions. Some of you have met me at some of these telescope events that I've done. If you haven't, my name is Mark Benson. I live in Oak Park, where I think many of you live. And I do the telescope nights that the Park District helps me with. NASA gives me a really cool title called a Solar System Ambassador, which is a really fancy way of saying that I explain things to people that NASA is doing. Because even if you watched the news a month ago, let alone right now, which is even crazier, if you wanted to hear about what NASA was doing, you probably wouldn't hear anything on your nightly news about NASA. You wouldn't find a lot of hits about it. So they have people like me go around and talk to schools, do telescope nights, things like that. So thank you for joining in here. If you found this Facebook page, this is where you'll find other events in the future, hopefully other online ones if this keeps going like this. So that's a little bit about me, but now I'm going to introduce the person who is on the other side of the screen here from me, who's waving enthusiastically. This is Dr. Morgan Cable from the Jet Propulsion Laboratory. She is in California right now, where it's actually not a whole lot warmer than it is here where we are in Oak Park. She is a research scientist with the Jet Propulsion Laboratory. She's going to round out her resume, but she has worked on amazing missions, been part of amazing missions like the Cassini mission to the Saturn system. She's working on things that are going to go to Europa. She's working on things that are going to investigate Titan. She's been involved in lots of things. Astrobiology, very fancy way of saying searching for life. She's traveled all over the world, very interesting spots on our planet to better understand how life forms, how life survives, and to help where to look for it in other more remote places in our solar system. So she is joining us. So Dr. Cable, thank you for being here.
Hello, Mark. Thanks so much for having me and for organizing this. It's really nice to be able to reach out from my living room, and I'm sure we're all feeling a little bit isolated now, to be able to talk about some really cool science going on our planet and others in our own cosmic backyard. So yeah, like Mark said, I am a scientist. I am actually a chemist by training, so my PhD is in chemistry, and I came from Florida originally. I actually grew up right next to Kennedy Space Center, where the space shuttle used to launch from and where rockets are launching from. In fact, I think there was a launch recently. My mom still lives there. She was telling me she gets to hear those and go out and see those sometimes when we're not dealing with global pandemics. But yeah, so I grew up watching rockets go off and was always fascinated by questions like, are we alone? What is the rest of our solar system like? How did it form? How did we get here? And now, as a scientist at the NASA Jet Propulsion Lab in Pasadena, I get to answer, or at least try to answer, some of those really amazing questions. And it's a lot of fun. I love what I do, and I'm happy to answer some more questions. It sounds like, Mark, we've got a few about astrobiology and careers and all sorts of stuff. So why don't we go ahead and get started?
Yeah, thank you everyone who sent me questions in advance. The questions are off to my side here. Also, I will mention I do have a little bit of a cold, which is just a cold.
Just a cold.
So I apologize in advance. There's no way I'm going to talk this entire time without coughing. So my apologies in advance for that. You're not going to catch anything through my computer though, so you're good.
Wash your hands.
Yes.
Don't touch your face. Okay.
So I noticed, so again, this is the first time I've used this app to broadcast. So we're learning about it as we go. I am seeing some public comments going on the side of the screen, which is cool. I honestly didn't know that I was going to see those there. So that's great. A lot of you sent questions in advance. I'm going to start working, kind of winding through those. If I see something interesting pop up on the side, I can pull from there too as we go. It's very, obviously, you can tell it's very, very formal process here.
Hey, I'm in my formal blazer.
You did dress up.
See,
Yeah, And honestly, it probably wouldn't be that different if she was actually at work. So it's a comfortable place. So let's see. And I was joking. I'm wearing my Jet Propulsion Laboratory hoodie because I'm the person who wears the band shirt of the band they're going to see in concert. So I'm wearing that.
So we're good.
Yeah. So I think first up, before we get into the questions people sent in, I'm actually kind of surprised that this wasn't one that people sent in. So let's start with how is the coronavirus affecting what you do and other aspects of NASA that you are aware of? What is still happening? You mentioned there's a launch the other day, so obviously some things are still happening, but talk a little bit about how this has changed your job and what NASA's up to.
Yeah, so I count myself really fortunate to be one of those people who has a job where I can work from home. And a lot of scientists are in that same category. And so the NASA Jet Propulsion Laboratory right now is at a stage or level 4. There are 4 levels. We're at the top one, which now means that very few people, if any, are allowed onto lab physically. It's only for what they call mission critical things. So things where you absolutely have to have someone there working on some hardware that is really important to keep, say, a launch from slipping or something like that. All of us who are able to work from home are doing so. So you can see my beautiful home office on my couch in my living room, and I've been attending many a WebEx and things like that. Wash your hands. And but there are certain engineers and other people who work for NASA centers who aren't able to do some of that work from home. And so we're doing our best to keep people safe for now, and we'll be following the directions and directives of both NASA headquarters and, depending on where the NASA center is, what's going on locally in terms of when we can resume work back at our NASA centers. So yeah, I'm not sure when that's going to be, but I have carved out a little bit of extra time to work on some of these papers for some journals that have been in my backlog. So at least that's been good. And I'm trying to get outside and take a walk at least once a day, away from other people, but still trying to get outside. And I encourage others to do the same, and maintaining 6-foot distance in between everyone.
Yeah. So when I've been holding events end of last year and start of this year, I would talk a lot about how in the future, 10 years from now, we're going to look back and think, how did we get to the amazing things we're doing right now? And I always felt like 2020 was a big part of what those big plans were, especially in terms of getting human astronauts launched from Florida. Again, a lot of the work that's going into that this year. And obviously that's not your particular corner, but there's also a rover being launched from Mars, Perseverance, Percy. So I've always felt like 2020 was building up to be large. Have you heard about is there anything that you can say about things being canceled or not going to happen at all? Or do you feel like plans are still happening?
So I think it's too soon to say, at least for Perseverance, the Mars 2020 rover. As far as I know, things are still on target for the launch as planned. We actually JPL built that rover and integrated all of the instruments on board, and we delivered it about a month and a half ago. I don't know, it's hard to tell passage of time, but before the coronavirus really had an impact.
Yeah.
And so hopefully it's at the Cape now and getting ready for launch. And so hopefully things will still run smoothly. I believe that's one of the mission critical items that they're allowing people to work on still through this shelter in place or whatever it's called in your area. Stay at home.
Yeah, that's pretty much what it's called. Another, we've talked, I showed my hoodie and we talked about your work at the Jet Propulsion Laboratory. We probably should preface that a lot of people are used to everything just being referred to as NASA. So maybe JPL and Jet Propulsion Laboratory might throw some people off. So if you want to give us a quick little primer on what specifically Jet Propulsion Laboratory is versus compared with just macro NASA as a whole.
Sure. Yeah, so NASA has its headquarters is in Washington, D.C., but there are a bunch of NASA centers all over the country, right? There's Johnson Space Center, which is in Houston, Texas. That's primarily responsible for the crewed type missions, so the ones with people. There's Kennedy Space Center near where I grew up in Florida, Cape Canaveral, that does a lot of the launches. There's NASA Ames Research Center up in the Bay Area. And there's JPL, which is a little bit different than most of the NASA centers. The best way to explain it is that all of the stuff at JPL is NASA stuff, but all of the people, technically, we are Caltech employees. So JPL has this wonderful partnership with Caltech, which is just a few miles down the road. And it's really nice because, for example, I started off as a graduate student at Caltech. Even during my PhD, I was working in a lab at JPL. I had 2 advisors, one here and one there. And because of that, we get a lot of engagement of students, both undergrad, graduate students, postdocs. We interface a lot and interact with the professors and their research at Caltech. And that partnership has, I think, enabled us to have a great pipeline of brilliant minds coming in and being able to work on planetary science and astrophysics and all sorts of fun things at JPL. But we focus on robotic missions. So extending our senses, as it were, to places that where we haven't sent people yet, or we hope to in the future. We tend to want to send robotic explorers first, just to check things out before we send the really precious cargo, which is the people. And so we are responsible for big missions, things like the Mars 2020 rover, the last Mars rover, MSL, and even the slightly smaller ones, Opportunity and Spirit. We are responsible for big spacecraft like Cassini, which explored the Saturn system. I was lucky enough to be a part of for more than a decade. It was there. It's 13, 14 years. It was a long time. And we're also responsible for small missions. For example, my husband's an engineer at JPL, and he worked on a CubeSat, the first interplanetary CubeSat called Mars Cube 1. And so it's a really amazing place. And it's also where all of the data from anything that's outside of Earth orbit, whether we built it, NASA, or ESA, or JAXA, like any of the other space agencies in the world, it all goes through the Deep Space Network, which is managed by JPL. And this image, what you're seeing right here, this is what we call the dark room. That's where all of those signals come in from the Deep Space Network. It's actually recognized as a National Historic Landmark. And so we get all that data, and then we distribute it around to whoever is responsible for the spacecraft or that instrument. And so it's really neat to consider yourself kind of a hub. Our former director of JPL, Charles Alachi, used to call that room the center of the universe because
there's a plaque on the floor, I think.
Yes, it kind of is. And yeah, I think we've had 7 marriage proposals happen in that room. Just saying.
Wow.
It's a pretty cool place.
It is. I was lucky enough to be there when they ended the Cassini mission. My one time to be in that room. I that picture that I put up on the screen. I snapped that picture. I should have spent more time talking to people, but I was really just kind of wandering around taking pictures because I was kind of in awe. But I do remember there being a plaque on the floor somewhere, I think, that said "Center of the Universe." Somewhere in the middle aisle, I think it was there. So,
well, Mark, if you ever come back to Pasadena, I'll bring you back and we can explore that place again, and you can take some time and really get a feel for it.
I kept asking if I could drive a Rover, and they just weren't down with that. It wasn't really insulting, but it just no one was really interested. Yeah, no one was interested in that. So.
No, that actually is a job. You can be, you can apply to become a Rover driver. And I have a couple of friends and colleagues who get to do that on a daily basis, and they love their job. So if you're interested,
even let me drive Curiosity's. They wouldn't even let me drive Curiosity's twin, which is in the lobby of that other building. I thought I could at least drive the practice rover, but they wouldn't let me do that either. So they kept me away from that one. So I'm going to get rid of, new technology, we're all learning. So I'm going to get rid of that picture and hopefully get us back to the screen we were on. There we go. I think that worked. Okay. So doing some questions in no particular order. We'll try to go a little bit in why not? We'll go in a logical sense tonight. A lot of people asked kind of overlapping questions. And one of the more common questions was, when did you become interested in space and science? What got you interested? Why do you do what you do? Where did you study? Things, more foundational things like that. So talk a little bit about your interest.
I can do that. So I already mentioned that I grew up in Florida, right next to Kennedy Space Center, what I didn't mention is that my dad actually worked for Kennedy Space Center.
Oh,
He
okay.
was a chemist too, and so I have a brother and a sister my same age. We're actually triplets, not identical though. Don't worry, there aren't two other Morgans running around. But we all studied science, but I think I followed most closely in my father's footsteps, and I was always interested in asking questions and then going and trying to figure out the answers. And even at a young age, from like elementary school, I was involved in science fairs.
Okay.
Our dad encouraged us to do it. All three of us did it. And by the time I was in middle school and high school, I was already asking questions like, is there life on Mars? And I did a science fair project about that, where I was able to. My dad was also a part-time professor at a local community college, and so one of his biology professor friends allowed me as a high school student to go in and do some experiments in his lab with a certain type of bacteria that grows in conditions similar to the Mars subsurface. It lives off of a reaction between lava, or volcanic rock, I should say, and liquid water, called
Okay.
serpentinization. And when those two react, they can create hydrogen and CO2 and things like that. And so I basically did that in these little like gas bags where you can make an anaerobic atmosphere, and did that in 8th grade and in 10th grade. Um, and my dad, I remember we had to check the growth of the bacteria every 6 hours. We were driving like to the community college to count colonies every 6 hours. And it was such a cool experience though, because
Yeah.
I got data, like the bacteria grew over a 2-day period. And I think at that point I was hooked. So
Yeah.
I studied chemistry in undergrad, and then I did something that's really important. I did an internship. I actually did more than one. I did one at a university, and I did one at a NASA center. And for me,
Okay.
this was a great way to get exposure to what it was like to work in a NASA center, and also have them get exposed to me. So during that internship, I actually met one of my two PhD advisors, the person from that summer. It was the summer of my junior year. Ended up becoming one of my two PhD advisors when I went to Caltech for grad school. And so it was a great experience. And if anyone's interested in working for NASA one day, I strongly recommend it. Internships are great. They're 10 weeks long, so it's not the end of the world. You get to live someplace else, and you get to figure out if it's something you love or something you hate. I did one internship that was more organic chemistry related. It was like a 20-step synthesis. After 10 weeks, I ended up with like this much of some new thing no one had made before, which is cool.
Yeah.
But by the end of that summer, I realized that wasn't where my heart was. And at the end of the NASA internship, I was like, oh my God, this is amazing. I want to do this forever. So I
Yeah.
strongly recommend anyone who's interested, do an internship. It's a great way to figure out if this is something that suits your interests and kind of fits with what you would like to do for a career.
And you went to Caltech, correct?
I did. Yep.
Okay. Because definitely people want to know what school you went to, which school had the magic power to put you where you are. So,
Well, okay. So
and what did you
Caltech is
study?
great school,
What the,
but there
obviously
are
if you like chemistry, but yeah.
yeah, I would say it matters less where you went to school and more what you studied
Okay.
or the type of work that you did, especially as a scientist, right? So I'm a chemist. That's great, but I studied the specific part of chemistry that was involved with how to detect biomolecules and how to search for life and things like that. And that's, I think, what got me into the role that I have now as a scientist at NASA. So, and you don't necessarily need to study chemistry. There are many fields that have links and ties to planetary science. That's one of the things I love about this field is it is so interdisciplinary. So I know people at JPL who have backgrounds in astrophysics, geology, geophysics, geochemistry, biology, oceanography, like the list goes on and on. And so
Yeah.
I think if you're interested in working for NASA, don't just get a degree in something because you think that that's what they're looking for. Do not do that. Get it, like study something you're passionate about, something that you would do for free, that you will do on nights and weekends, that no one has to like twist your arm to do. If you found that thing, study that thing. And if there's a way to connect it to what NASA is doing, you'll probably find it. And if you're doing that, then that will line you up perfectly to do work for a NASA center. And so we have people from all sorts of walks of life, different colleges. I would say at JPL, about a third of the people who work there have PhDs. about a third have master's degrees, and about a third have bachelor's degrees. So it depends on what field you're studying, what you want to do with that degree. There are a lot of different options. There's no like one right path to get to a place like NASA. I guess, does that make sense?
Yep, it does. So we have a very specific, that was a very general question about school. We have a very specific question. I know you're going to be very excited about this one.
Oh, yeah? Okay.
I don't have the name, but someone posted a question that their 7-year-old niece loves math and wants to know if you love math as well. And
I love math.
Yeah, nothing specific, just wants to know if you love math. So.
I love math. I actually took so many math classes in undergrad because I loved it that I ended up with a minor. Just kind of happened.
Accidentally, you just tripped over a minor.
Yeah, and I actually have something around there. It is. So, my husband actually got married in this hat. It's a little dusty, but Mark, do you know what this is? Does anyone online know what this is?
That I'm glancing at
it's a Mad Hatter hat, but we've fixed it.
Is the Mad Hatter hat? Yeah.
I'll give you a hint. Sometimes when two nerds get married or two professionals, who both have careers, they call it solving the two-body problem. You heard that? This is the solution to the two-body problem of orbital mechanics. So I guess it's more physics but it's math. Like physics and math.
There's a lot of letters. There's a lot of letters in that. Are you sure it's math? I didn't see a lot of numbers there.
Well, numbers, letters, it's all, variables. It's fine.
Math isn't my, I took a lot of math classes second and third times.
I do love math, but I should also say you don't have to be a math whiz to end up working at a place like NASA. There are plenty of jobs, career paths available for people who are not strong in math. I would say as a scientist, it certainly helped me, but I bet I could find friends and colleagues who weren't as excited about math as I am, and they still work for NASA.
Yeah.
I think the biggest thing is to be persistent. If you have a dream, go for it. Don't let anyone else tell you that that's not what you should be doing, because they don't know you as well as you do.
Yep. Good. I'm going to glance over at my list of questions here on the side here, see if I have another question that's kind of best falling in line with that. We're going to switch to kind of your specialty here, which is searching for life. Let me find some specific questions about the search for life here. So far, a question from Luke, who's 10 years old, wants to know, so far, have you found any planet that may support life?
Yes, we have. Although they tend to not be planets, they tend to be moons. And I'll talk about a few of them. Actually, there's one, if you can see the background behind us, this is one of my favorite places in the solar system. This is Saturn's moon, Enceladus. Not Enchiladas, it's Enceladus. And this is an amazing place. Actually, Mark, you've got a poster behind you that also has Enceladus.
I do. Actually, it's there. It's one of my favorite places. And I have another picture of it too. I can put up another picture here. It's a little hard to see in the background. So go ahead.
So Enceladus it's a relatively small moon. It's about the size of the state of Arizona, but small things can be mighty. And this one definitely is. When we got to the Saturn system with the Cassini spacecraft, we didn't expect to see any liquid water out this far. We figured it was way too cold for liquid water. And the Cassini spacecraft was able to fly by a lot of Saturn's moons. And one of the things that surprised us a lot about Enceladus was something that was coming out of its south pole. Now, in this picture here, you can see down at the bottom, there's like these 4 sort of bluish stripy things. We call those, we call those tiger stripes because it looks like a tiger went, really big tiger. Those things are about, they're about 3 marathons long, and there's about a marathon in between them. So like 40-ish kilometers, right? 42 kilometers, isn't that a marathon? Answered everything? I think it is.
Yes, 42.
Yeah, so these things are really long, giant chasms. They're big gashes. Enceladus' surface is made of ice, and these are gashes in that ice that actually go all the way down to a liquid water ocean, just like the water that Mark was just drinking, except probably salty. Actually, we know it's salty here. The reason I love this moon so much is because it's sending us free sample from its global subsurface liquid water ocean into space. So it's like, NASA, you want to see if there's life somewhere else? Just come on by, come grab some. It's free once you get there, which takes a little bit of money and time, but that's fine. And so um, Cassini flew through that plume, is what we call it,
We're
and
gonna find that
stuck its
in here.
tongue out. Yes, that's the plume. So you can see that. That's one of the beautiful images Cassini took, where it's backlit by the sun, and so that's why you can see that that's water vapor. So a lot of water, but also salts. Cassini also found complex organic molecules, like not just little things, big things, up until the mass cutoff of the instrument. Cassini's instruments were not designed to look for life, so they weren't optimized to search for sort of biomolecule kind of things. They were optimized to look for smaller things, what we call volatile, stuff that we thought would be out there. And we found that stuff, but then we also found this other stuff that was really tantalizing. And that's one of the big reasons why we want to go back with a specific payload designed to study the molecules in that plume and potentially on the surface too, depending on whether or not we can get a big mission or one of NASA's smaller missions to go there. There's all sorts of different concepts out there for how we might go back and collect some of this stuff and see if the ingredients for life are there or if life itself is there. So that's one place.
How possible is it? How possible is it to get down in there and go for a swim in the ocean that covers the inside of that place?
Okay, that's a really good question, and there are some very smart engineers who are already thinking about that. At JPL, there's some people working on this sort of snake-like robot that could kind of slither its way down into one of those cracks, and we have some ideas about how big they might be, even at their smallest point. So we're looking at ways to, even if it was only like this big around where the stuff is coming out, if we could get down in there. And it turns out the forces of the plume stuff coming up are about the same as if you were to, say, be a rock climber climbing against the gravity of Earth's pull. It's about that force that you would need to counteract. So Enceladus has very little gravity. It's 0.01 g compared to 1 g here on Earth. So it's 1% of our gravity. So you don't have a lot pulling you down. And then this force is pushing up. So you'd sort of have to go against that force to go down. But you could do it. So engineers are working on concepts like that. There's one called EELS, is the one I'm talking about. It's a Exobiology Extant Life Surveyor. There was a talk through the KISS, the Caltech, the Keck Institute for Space Studies at Caltech. So if you do kiss.caltech.edu, you can find Kalen, who is the lead engineer on that, Kalen Carpenter, and I gave a talk on it. And you can see some cool videos of like what we think this thing would look like. Anyway, so that's neat. But there are also these melt probes that people are designing too that wouldn't even need to go through a crack. They could just like melt straight through the icy crust and get straight to the ocean. Those,
wow.
There are some challenges, unique challenges involved with either of those kind of scenarios, but we're working on both type of concepts. And so hopefully in a decade or two, I don't know how long it would take to get one of those things there, but that would be really incredible. Currently though, given the technology we have right now, we could still launch something that would go into the plume, stick out its tongue, grab some of those snowflakes at 5 kilometers a second. Wouldn't recommend it with your tongue, but we have instruments that can do that, and look for biomolecules. So we could still address the life question, even without getting into the ocean itself. But it would be nice to confirm things by going around down there and swimming and hopefully seeing like a squid or something go by. That would be cool.
So Ocean Worlds is it's the part that you're working on. It's a big part of when I do events around here, I talk about these ocean worlds. And I wanted to ask, because someone actually just posted a question in the little chat here. Why are we finding the moons to be more interesting than the planets? Like, why is it the moons that are having these things? Why are we finding moons with oceans and not planets with oceans? That type of thing.
Okay, so what we're finding, except with Earth is in what we call the Goldilocks Zone. It's in this really happy, perfect distance from the sun. So like, okay, so So this is the sun, right? My water glass is the sun. Or wait, I'll be the sun, and this will be the Earth,
There's
right?
more
So if
water on
yeah,
Earth. Yeah. Yeah.
if it's too close, then it's too hot, and all of this water would be boiled up into steam, right? And it would be gone. It wouldn't be suitable for life. Too far away, and now it's too cold. All this water freezes if it's on the surface, right? And so it's frozen solid. That's not so good for life either. So if you're in the perfect distance where you're not too hot, not too cold, that's great for oceans on the surface. Now, when it comes to oceans further out, what we found is these are all underneath a crust of ice, and we think that they're staying liquid because of gravitational forces. And so you need a few other kind of heavy hitters in that part of the solar system to do like this gravitational tug of war that cause what's called tidal flexing. So if this is the moon, basically what happens is for Enceladus or Europa, which is around Jupiter, the other moons sort of yank and tug on it, and so does the giant planet. So it sort of does this as it orbits around. For Europa, there's Ganymede and Io that both yank and tug on it, in addition to Jupiter. And so for every one orbit Europa does, Ganymede does two. Wait, no, it's the other way around. For every one orbit Ganymede does, Europa does two. For every one orbit Europa does, Io does two. And so they do this thing where it's sort of like if you were pushing your friend on the swing set in the playground, if you push him just the right time, you can get him to go really high, like maybe higher than your parents were okay with if they were watching you. And so that's what happens. And Enceladus has the same thing with like Titan and Dione and a few other moons, but it's a weird resonance. It's like 7 to 11 or something funky like that, but it still happens. And this is why we could even have liquid water further out. There are some guesses that maybe Pluto could even have a liquid water ocean, partly because of some funky resonance with Charon, but also partly because it may have this like layer of clathrate that's like insulating. Clathrate's just like this fancy name for a cage of water with something inside, and it can insulate better than normal water ice can. Anyway, so there's all sorts of cool things that are why we are finding liquid water in places we did not expect it. And what blows my mind is that Patty commented that her daughter was talking about the TRAPPIST-1 system in the chat over here, over there.
Yeah, right there. Yeah, the other way.
Yeah. So yeah, we're finding places like the TRAPPIST system that have at least 4 planets in that Goldilocks zone. But what about the planets further out? If they have moons, if these exoplanets have exomoons that are like Europa or Enceladus, Exo-Europa, Exo-Enceladus. This sounds cool.
Yeah.
There could be life there too. And so it's totally opened up, for me at least, where we might search for life, not only in our solar system, but in other exoplanet, exosolar systems that we're discovering, which is nuts.
So someone asked way early on, and I tried to make note of it so I wouldn't forget it. Actually, honestly, I wasn't even sure if you were seeing the comments on the side. So I'm glad you are.
Yeah, these are awesome.
Yep. So someone asked if you think it's more likely that we would find life in our solar system or an exoplanet first.
That's Graham. Hi, Graham. He's awesome. Yeah, so it depends, I think. Here in our own solar system, we can do some very sensitive tests, and we have an advantage where we could actually go and land on one of these places, or like we were talking about, get down into that ocean and slurp up some of the ocean water, filter it, and look for biomarker molecules or cells. When we're talking about looking at exoplanets, we can only use telescopes right now, spectroscopy, things from far away. And so we could look for evidence of certain gases in their atmospheres. For example, oxygen, which we have in our atmosphere, because we're breathing it, that's great, tends to not hang around long. It gets degraded by, radiation from the sun or from other things. And so sometimes that can be considered a biosignature. Methane gas as well, which is weird because Titan has a ton of methane. We don't see any obvious signs of life so far. So that's one of the mysteries of Titan is why isn't the methane all gone? It should have disappeared in 100 million years, and it's still there. Yeah. But we could search for these gases. There are some other biosignature gases as well. But I don't know if you could convince the scientific community or just the general public to be like, hey, look, see the squiggly line? There's a dip there that tells us there's methane over here. And that means we think there's, it's a little bit harder than if you had, say, a techno signature. technosignature is something like a radio signal from an intelligent
Right.
race. This is something that SETI has been looking for decades now, and I think they still have their citizen science program where you can log on and help that search of filtering
We
out.
do, yeah. Yeah.
That I think if we find that, it's like obvious. Well, there's life somewhere else. That's great. Oh gosh, I hope the
Right.
technology is not way more advanced than ours, or if it is, I hope they're peaceful. Like that kind of thing, for sure,
Yeah.
we should keep looking. But in terms
Or
of
as we
our
were
own solar
talking about,
system,
or as we were
yeah,
talking about earlier, finding dolphins on Enceladus, the Enceladolphins, as we're referring to them.
enceladolphins.
That would be being able to just snap a picture of an Enceladolphin would be pretty convincing, I would think, over a squiggly line of
Yeah,
methane.
yeah. So,
So
Patty
speaking of that, what
Bowers
do we
says
think?
she wants to be an exoplanetologist. That's awesome.
That's a big word. Yeah, that's a big word. What? So I'm glancing at some of the other questions people had sent in, and they're kind of all over the place. I'm trying to squeeze them into when they make most sense. What do you think? What do you think we're going to find in turn? We were joking about finding dolphins swimming around on Enceladus, but what do you actually think when we say, okay, we found life somewhere? What does that mean? What do you think we're going to find? What does that look like?
Well, okay, so we have some theories, and one of our best, sorry, I shouldn't touch my face. One of our best indicators of how the types of life we might find and the diversity, the abundance, things like that, are based on how much energy is in the system. Here on Earth, almost all of life as we know it, you, me, your plants, your dog that is still hopefully hanging out by your feet.
Yep.
Yep, cool. We all depend on sunlight, either directly or indirectly. So plants, it's direct, right? They absorb sunlight, photosynthesis, they use that to generate the molecules that they use to keep their cells alive. We eat the plants or sometimes eat the animals that eat the plants, and that's how we get most of our energy. These worlds, like Europa and Enceladus, if these oceans were to have life in them, they're completely cut off from sunlight, right? They're under kilometers of ice. No light is getting down there. So they have to rely on different energy sources. We
I
think
think
the
I have
most.
a video that might help with this. Let
Huh?
me find it.
Okay,
Do
yeah.
you want the
So
NOAA video here?
say what, Mark? Sorry.
Do you want the NOAA video up here?
Yeah,
I can
go
put the
ahead.
NOAA.
Pull that one up. Yeah. So life in an ocean like this, well, we have some examples here on Earth that we could potentially use. And what you're about to see, this is a video from the National Oceanographic um, Administration. Wait, what's the second A stand for? Oh, crap. I should know that. It's from NOAA, National Oceanographic and Air. I'm going to look it up because I feel like I should know what that is. An atmospheric administration, right? Because ocean and atmosphere, of course, are very linked. This is showing a hydrothermal vent down at the seafloor. This is at the Mid-Atlantic Ridge. This is something we call black smoker. There are also white smokers. Some of them are rich. Black smokers are rich in things like iron and sulfur. White smokers tend to be more rich in silica and calcium. But what you can see here is there are crabs, there are shrimp. It's not just bacteria. There's a complex community existing here, and this is as far removed. Thank you, Graham and Julia. Atmospheric, yes. It's as far removed from sunlight as you can get. Right? These are surviving off of either geothermal or chemical energy. Essentially, the conversion of things from either an oxidized form to a reduced form or vice versa. So basically, shuttling electrons around. And life can tax some of those chemical reactions and sort of charge a little bit for moving an electron from here to there, and they can get some energy from that reaction. And communities like that, they can form, as you just saw, multicellular life, things like shrimp and octopus, but probably not a whale. And sorry, Mark, probably not an enceladolphin. I mean, it would just think about how much a dolphin would have to eat and think about how many of those hydrothermal vents might exist. And so I think we would probably be looking for evidence of microorganisms or smaller forms of life that can live off of less energy. But we're trying to be, and I should say that we're being as agnostic as we can when we search for life in these places. So we are designing experiments, suites of instruments, not just a single experiment, right? We want something where we could find maybe 5 or 6 or more independent lines of evidence, where if each one says, okay, there could be life here, this is weird. If it was abiotic, no life, we wouldn't be seeing what we're seeing. If you see that one
Right.
time, one experiment, that's not very exciting. If you see it with 5 or 6 or more, then you're like, okay, there could be something here.
Yeah. Okay. Let me glance back on my question list here. We've certainly answered a few of them just as we've bounced around. Let's see. We got that. We were talking earlier, before we came out, we were talking about planets or moons that have rovers or space probes that they've already looked for life. We know that Mars, the rovers are going around there, looking for all sorts of things, digging and driving, and hopefully soon flying with drones. But any other spots? We talked, going swimming on Enceladus, but any other spots where we're looking for life? We're on the ground looking for life in our solar system.
Yeah, there are a few either in progress or things that have already happened in the past. Like you talked about Mars and the rovers that we've had, but don't forget the Viking landers back in the 70s. Originally, their goal was to search for life. They had
Right.
3 life detection instruments aboard, each of them, Viking 1 and 2. Well, one of the tests was positive for life, one was negative, and one was ambiguous.
Oh, that's
And
perfect.
yeah, one of the issues was all 3 of these tests relied on sort of a bulk measurement where they scooped up some Mars dirt or soil. I guess dirt implies organics, or does soil imply organics? Regolith. Well, we'll go with regolith. Scooped that up and then dumped some liquid water or water with nutrients, and then looked to see what would happen. And so for some of these, the gases evolved, seemed to indicate that there could be organisms there. But the problem is, now that we've learned that perchlorates exist on Mars, some of these salts that can also be very reactive, turns out if you take perchlorate and you sort of dust it with some gamma rays, you can end up having a very similar reaction to
Sure.
what we saw that originally had been attributed to a life-like metabolic reaction. So there are some a lot of lessons that we learned from Viking. When we go search for life again, we're going to be relying on a whole bunch of different tests that are not necessarily metabolic like that. Things where we will search for patterns in organic molecules that are unusual, that could only be formed if life had affected them. We'll be looking for, hopefully, morphologies, right? Cells, individual cells, or evidence of cells or fossils. For example, the new Mars rover, Percy, has a Raman spectrometer on board that can hunt down organic molecules at pretty decent limits of detection. I don't remember exactly what they are off the top of my head. And it also has a bunch of microscopes and other very good imaging systems to be able to look for evidence of past or present life. Now going further out, aside from Mars, the Rosetta spacecraft, which was the European Space Agency built that one, had the Philae lander, which, as we know, sort of barely hung on and didn't quite.
The comet, right? Yeah.
Yeah, it was around the comet Churyov. I can't pronounce the full name of the comet, but that also had some life detection type of instruments and detected glycine, an amino acid, which is pretty exciting. Now, we see amino acids in comets all the time, but one of our potential biosignatures can be looking at those amounts of amino acids to each other. So when life is not around, if you were to just like be in a chemistry lab and try to make an amino acid, chances are you would make glycine. It's the simplest one. Um, Alanine is another simple one. They're just energetically easy to make. But life can't make a lot of fascinating proteins if it strings just glycine together and tries to wrap that up and make a protein. It can't really do a lot. So when life is involved, you tend to involve some more exotic amino acids, things like serine and phenylalanine and threonine and cool things like that. And so if we were to find those more exotic amino acids in abundances that were kind of weird, that would be a biosignature. But if we see just glycine, just kind of the boring one, that's less exciting. And so we did see glycine on the comet that Rosetta visited, but unfortunately we didn't get to see any others. At least I don't recall seeing any reports of any life-like ratios of amino acids.
Sure.
Otherwise, let's see what else is going out there. So the Europa Clipper mission, which is being built right now, we're still
Yeah, I
set
was going to bring
for
that up.
launch in the 2020s sometime, and it'll take, depending on the rocket we go on, maybe like 3 to 6 years to get to the Jupiter system. Space is big. The Europa Clipper mission is going to have some advanced instruments that could look for biomolecules coming off of Europa's surface. Europa has a bunch of micrometeoroid impacts and things hitting it. Just like Enceladus, it's got ice on its surface, and you see that brown stuff. We're not sure if that's either salts or organic molecules or both, as one of the things that the Europa Clipper mission is going to answer is really exciting. So it's possible that that mission could detect biosignatures if they're on the surface and they're sputtered up into space. It's also got a very fancy camera called an imaging spectrometer. It's called MISE, a mapping imaging spectrometer for Europa. So I'm a miser because I'm on that instrument. And that would be able to map those organic molecules as well if they're there. So that picture you're seeing right now that's got those kind of cross marks, those are some giant cracks in the ice of Europa. There's also these things called lenticulae. You can see some of those dark features. That's actually, what is it, Greek for freckles, Latin for freckles. That may indicate some regions of localized heating. If MISE were to take an image of that, it could also, on top of that, show you where the organic molecules are and where the salts are and things like that. So we can get composition from that instrument.
So if I understand from this little video here, the idea is to land.
Yeah, okay, so this is a concept. This hasn't been funded by NASA yet. It's gotten some funding for technology development, and there are a lot of teams out there working on instruments that could go aboard something like this. This is the Europa Lander mission concept. This could land on the surface of Europa. It's got these neat things. They're not called legs, they're stabilizers, even though they have knees and feet. They're not legs. And the reason for that is because they don't move. So what it would do is if it were to come down and land on the surface, those stabilizers would lock in place. So if we were to get near sort of a steep bit or a big rock, they would lock in place and hold it there. So the rest of the body would stay level. But then it does have an arm. It would have an arm like this that could move. And boy, the engineers that are designing stuff like that, they're awesome. This ice that we're showing a concept like this cutting into it's about 80 to 90 Kelvin, which is minus 180 something degrees Celsius. It's really cold. Don't ask me what it is in Fahrenheit. I'm a scientist. We don't work in Fahrenheit. But at those temperatures, even water ice has a lot of properties of something like granite. It's basically like rock at those temperatures. And also metal gets kind of brittle, some types of metal do. And so the engineers have been working on designing drill bits and cutting tools to be able to handle even a tough sample like that. And I remember one of the chief engineers who was working on this, he said he was on his treadmill one morning and he was trying to think of like what would be the most gnarly sample he could possibly come up with. And this is really evil. So he came up with this thing. He was like, okay, take cotton balls and stretch them out so you get like those fibers, and then put that in liquid water and then freeze that in liquid nitrogen. And he said that thing destroyed about a third of their cutting tools that their prototypes they had been working on. But they tested some that worked, that could even cut through because the fibers, like I guess they cut up or they caught up the blades. So they're working on all sorts of cool ways to be able to handle incredibly tough, incredibly challenging samples, such that we could grab some of that stuff, bring it into a lander concept belly where the payload, the instruments are waiting, and they could divvy it up and look for cells or organic molecules or things like that. And so that concept, we're hoping gets some more funding to keep moving forward because it's great. And that could land on Europa, but we could also design a similar thing. Actually, you wouldn't even need to redesign it. You could just plop that thing on Enceladus or Neptune, Triton's moon, which is really wild. Have you guys heard about this one? It's orbiting the wrong way. Like everybody else is going this way. And we think that means it might be a captured object from the Kuiper Belt or further out. Neptune has only been visited once by Voyager, and that's it. And it was just a flyby. It was like, took some cool pictures. Oh my God, there's cryovolcanoes. Holy crap, this is a cool place, and we're gone. So Triton deserves a dedicated mission. And actually, NASA has down selected in its Discovery program, which there's like flagship missions, which are really big. There's New Frontiers missions, which are not quite as big. And then there's Discovery missions, which are usually pretty small. Like InSight is a discovery mission, the one that's drilling into Mars' surface.
Right now, yeah.
Yeah, Mars is really close. It's easy to get to. That's cheap. Getting all the way out to Neptune is super hard. But a team proposed a mission to go to Neptune's moon Triton called Trident, and it's one of the 4 that have been down selected. There are 4 missions, 2 Venus missions, this one, and one that would potentially go to Io, Jupiter's moon Io. So some poor review board has the tough job of now picking of those 4, 1, maybe 2. So it's got a 1 out of 4 chance of making it, which would be amazing. Because Trident, I think is the name of it, but Triton is just a super cool place.
Well, yeah. Okay.
Yeah. Let's see what else. Oh, and then one other mission I should really talk about. Dragonfly.
Dragonfly. Yeah. I've got something on Dragonfly.
Yeah, I think you do. I think I sent you something. So Dragonfly, I'm so stoked. This is my first mission I've ever been an official co-I on, so I'm like really excited. This is an 8-bladed helicopter, but it's the size of the big Mars rover. So picture something the size of a car, take the wheels off, put 2 skis on, like you're going skiing, and then give it 8 helicopter blades, 4 sets of 2. This is going to Titan. Yes, this is going to Saturn's moon, Titan. It's the largest moon in our solar system if you count its atmosphere. If you don't count its atmosphere, then Ganymede is a little bit bigger, and we'll let Ganymede have a win because Titan, I think, is way more exciting. Titan, right over there. It's bigger than Earth's moon, and it's got an atmosphere that's so thick, it's 1.5 times thicker than ours. So you would not need a spacesuit if you were standing on the surface of Titan. You would need a heck of a parka, though, because it is minus 183 degrees C on the surface. It's 90 Kelvin. Very cold. But yeah, you wouldn't need a spacesuit because the pressure, it would be like if you held your breath and went down to the end of your swimming pool. That's about the pressure you would feel. It's about 1.5 bar of pressure. And so Dragonfly turns out concepts where instead of driving on the surface, you do these hops where you fly hundreds of meters to maybe even a few kilometers to tens of kilometers. Turns out this is way more efficient to get around in a place that has a thick atmosphere and not a ton of gravity. It's got about the same gravity as Earth's moon. So actually, if you, Mark, were standing on the surface of Titan and you had wings and you flapped them, you could fly. So this idea isn't quite as crazy.
I'm down for that.
Yeah, so Dragonfly is, it's the PI is Zibby Turtle, who's at Johns Hopkins University, the Applied Physics lab there. And the team is assembled from a whole bunch of places. There are a couple of co-Is like me from JPL, from other NASA centers and other universities. And the goal is to try to understand if Titan's surface is habitable. And we do have some science goals to search for biomolecules. We're not exclusively saying we're going to look for life, but that's because we're not going to put it as a science requirement. But gosh, if it's there, we have the instruments to see it, if it is.
Now, there is already a dead robot on Titan right now, is there not?
There is, yes, the Huygens lander.
Very few people know that, I found.
Yeah, so when Cassini first got to the Saturn system in 2004, it did some close passes of Titan. We actually used Titan and its immense gravity and its atmosphere to sort of help torque and slow Cassini down and then be able to alter its orbits as it was going around Saturn. So we could tweak it up or down out of the equatorial plane to get some really beautiful views of like that hexagon that's at the top of Saturn's North Pole and all sorts of stuff like that. And we fly through the plume of Enceladus too, because you got to go down to do that. Anyway, so we went by Titan, and the ESA, through a partnership, we brought along the Huygens probe and dropped that in 2005. And so it had parachutes, and it slowly descended through Titan's thick atmosphere and took a bunch of pictures on the way down, took some gas measurements, it measured the Titan weather, so we could figure out where the clouds are. There are a bunch of aerosol layers too, like haze too, which is why it's hard to see the surface of Titan from space. And then when it landed, it was battery powered. That was on purpose, so we knew it wouldn't survive for an incredibly long amount of time, but it was able to give us some incredible data. And so now it's just sitting there, cold, and maybe one day some astronauts could go over and like take some pictures next to Huygens and be like, "Piece of history."
I love the idea of that, whether it's Huygens or whether it's one of the rovers, like that. At some point, someone's going to go to Mars, and they're going to be able to take a picture of themselves with one of the rover's cameras and send it
Yeah,
back. I love
and their
that.
kid's
Or
gonna be like, "Come on, mom, this is
reboot Oppie,
boring."
brush off the panels
So
and reboot Oppie and get it going again. I mean, I love the idea that someone's going to be able to turn one of those back on. That
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 would
would
be
be
amazing.
a lot of fun.
Well,
Yeah.
we at NASA and ESA as well, we over-engineer the heck out of everything that we send out there. So I wouldn't be surprised if you gave it, a jump start if it started right up.
So did you say ESA's the European Space Agency? I just want to make sure that I
Yes.
think you said that, but I don't remember for sure. So yeah, ESA is European Space Agency for those wondering. And the Huygens probe piggybacked along with Cassini on its way out there and then bailed off and went to Titan while Cassini did the rest of its voyaging around the system
Yeah,
before
and I should say that
finally
most of our big missions, like Cassini, like Voyager, we tend to have a ton of international participation. So not just scientists from ESA, but a bunch of other space agencies and just universities all over the world. So you don't necessarily have to be in the US to be involved in a NASA mission or an interplanetary mission.
Yeah. Let me get back to my questions here. I want to make sure as we're approaching an hour. So let me see what I have maybe missed on here. Somebody asked in the comments about if there are books, if there are things you read when you were a kid that maybe kind of inspired you into this. And I would just add to that question: were you sitting around reading a lot of nonfiction, or were you sitting around reading fiction, sci-fi books, and that got you into what the reality of this stuff is?
So I was obsessed with dinosaurs before Jurassic Park, before it was cool.
Okay, you were
Um,
there first.
Yeah, so I read a lot about those, and then I just, depending on whatever I was passionate about, I would try to digest as much as I possibly could. I wouldn't say it really turned to planetary science until I started that Life on Mars science project. And then when I started to do that internship when I was in college. But in terms of things to read, anything by Carl Sagan is amazing. Anything. Contact, I love that book. Read that book.
You need
It's
to read the
awesome.
book.
It's
The
cool.
movie's its own little wonderful thing, but the book is
The book is almost
it,
always better. No, not knocking any
it's very
movies
different.
in particular.
And there's a lot more in it. You understand it'd be like a 7-hour movie if they put that whole
Yeah,
book
yeah. So
into
anything
film.
by
There's a
Carl
lot
Sagan, the Feynman Lectures, Richard Feynman's lectures, you can hear them recorded and also read them. They've been transcribed, are amazing. Just the way he describes things like what fire is, it's just so cool. Like that'll get you hooked, just as well as I can't imagine anything else. See, what else did I read? Trying to think. I like science fiction, but I don't always read science fiction. I think it's
Yeah.
important to have hobbies a little bit outside of what you do. So I'm learning a
Well, you
language
ride a
right now.
unicycle.
I'm
You
learning
ride a unicycle,
Korean.
I understand.
Yeah, I do ride a unicycle also, um, which
It's a
is
little
fun.
bit
I
different.
do it on the mountains though, so it's good exercise. It's actually the reason I like it is it's the one thing where I have to be totally focused on what I'm doing. Like I can't let my mind start worrying about the things that I have to do at work or what's going on at home. I have to be 100% focused. So I call it meditation in motion, and I like that.
Okay.
I surfing almost gets me that too, but
Okay.
yeah.
All
Oh,
right, let me
Graham just posted a link. The Feynman lectures are free online, so check the chat
Yeah, there's that
window
link
for
to
that.
the side. I'm going to point the wrong direction again. See, I did it every time.
I
The
know
wrong
I keep
direction.
doing it too.
Over there. So the lectures, the listener. So thank you, Graham, for posting that. Someone had asked if there are any organizations or programs you've participated in or suggested where you want to go to find peers or mentors. I
Ah,
don't. They didn't specify as a kid or not. Well, they did say youth organizations. If you've had contact with any that you found was doing good things, or you were involved directly with any that
let's
even just seeing
see.
groups come around campus that you seemed like they were doing good stuff.
Well, the NASA Student Ambassador Program is great. So I encourage you to try to get involved in whatever local NASA ambassador type work is going on in your area. Any of the like robotics clubs or things like that are always great. I wish that there had been more of that when I was in like middle and high school. The first robotics challenge and things like that can be really amazing. Um, Otherwise, like I found it that I've just sort of always sought out mentors, whether it was formally or informally, whenever I had a question. So when I was doing that science project, for example, I emailed out of the blue this scientist from Arizona State who I'd read in Science News. He had there was an article about life on Mars, and he had written it, and so I just emailed him out of the blue. And was like, "Hello, I am an eighth grade student. I want to do blah, blah, blah." And this guy, his name's Ken Edgett. Now he's actually the PI of the MALI, the Mars Hand Lens Imager, which was on the
Okay.
last Mars rover. It's on the next Mars rover. And he ended up, we became pen pals. He sent a giant box of basalt because he was in Arizona out to me because that was like the best Mars rock replica. He ended up
Yeah.
coming out to visit for the launch of Pathfinder. And so I got to meet him when I was in eighth grade. That completely, I was like, holy crap, these people are, they're people, right? They're not like these, I mean, they're amazing, but they're actually approachable and you can ask them questions and they will not ignore you. And so that was amazing. And I can tell you, most of us who work in planetary science, write us an email. Don't hesitate to call. Like, get in touch with us and we'll give you advice if we have the time to do it. We really want to inspire the next generation because we want the sharpest, most brilliant minds to come and follow on in our footsteps. A lot of the missions that we do and the science that we're doing is not going to happen in just one human's lifetime. Some of these mission concepts that we're working on, like that snake robot, I would love to see that launch tomorrow. It's probably not going to. It may not even before I retire. And so I want some really brilliant scientists and some really smart engineers to take up that sort of mission and that love and that dream so it can keep going.
Yeah, when you talk about a what was it, 7 years for Cassini to get to Saturn? Is that the flight time? So you took the time to build it, to concept it, to build it, to launch it, wait for it to fly to Saturn, and then about 13 years of work. One of my favorite people that I very briefly came in contact with out there is Julie Webster. And I absolutely love her because after Cassini was over, someone asked her, you've been working on this for about 20 years, and that's a career. I mean, she spent all that time developing it, building it, fixing the fuse, standing inside the spacecraft itself, putting it together, and then project managing it, down to its last day. I mean, that's a career she worked on. And someone asked her what was she going to do now that it was over, and she said she just wanted to take about 2 weeks off and then build something else. And I just thought that was. She instantly became one of my favorite people just from that. Yeah. But that's a career. I mean, it's 20 plus years she spent on that mission, and a large part of that was just flight time to the planet that you were studying in the first place. So
she was a chief engineer.
Generations have to turn over on these projects.
Yeah. By the way, if you're looking for something to watch on Netflix, there's a series called 7 Days Out, and Julie is featured prominently. I also make a couple cameos. I didn't know she like drove 18-wheelers before she ever worked at JPL. I had no idea. She's my hero. I have such a crush on that woman. She's amazing. And I'm touching my face again. You find out about some of the amazing circuitous paths that people have taken to end up where they are. And I think it gives us a lot of hope that, as long as you're passionate and you're doing what you love, you're going to end up in a career that mirrors that, right? So that's the best. She's a perfect example of someone who's done something that she's loved forever. Yeah.
So we've crossed an hour, and I don't want to keep you too long, but because it's weird. It's dark here, but it's like dinner time by you. Come to think of it.
Yeah, the sun hasn't quite gone down yet. I don't know if you. Yeah.
So, but we've got two last questions here that I want to throw at you if we can do these last two. A 10-year-old was asking if studying the oceans on Earth helps you study oceans on other moons. And so, if studying oceans here, do you study the oceans here, and does that help you when you're looking for things out there?
Personally, I don't, but I have some colleagues that do. Because of these, what we call ocean worlds, these places like Enceladus, Europa, even Titan. It's got some cool, weird things happening on the surface, like liquid methane and ethane lakes. But if you go, tens of kilometers down through its icy crust, you also hit liquid water. It's got a liquid water ocean too. So we have all these ocean worlds out there, and we're realizing that there can be a lot of parallels to how oceanographers study our own liquid hydrosphere here on Earth. And so just in the last, I would say, 5 years, NASA has really started pulling in a lot of oceanographers, marine biologists, people of those backgrounds in to study and to help inform some of the science questions we're asking, some of the hardware. I mean, they're drilling in Antarctica, right? They already have like not necessarily melt probes. Well, now they do. They have a few of those now that they're prototyping for NASA, but like we're all working together to try
Right.
to figure out the best way that we can answer these questions. What are the right instruments to bring, and how to interpret that data? Because it turns out it's not as black and white of a problem as you might imagine. And so the more that we can learn here, the more that we can kind of fail here in a way and learn from those failures, such that when we send something somewhere else, we can be sure, or 99.999% sure that it'll work.
Right.
That's what we want.
And then let's see. The last one I had here kind of sums this up. We were talking very briefly about this beforehand. So we talked about finding life. We talked about how it relates to life on Earth. We talked about all these different missions that might find life. So you find something. What do you do? What do you do with it? How do you handle it? Do you bring it home? We've all seen that movie, and it usually doesn't end super well.
I have to
But what
find
do you
some
do?
wall space to clear off for my Nobel Prize. I have
Yeah,
to think
that's
about
it
where to put
first off.
that.
But yep.
No, these are really important questions. So NASA's actually signed a treaty, an international treaty saying that we would not contaminate any other worlds with Earth life,
Right,
but also that we wouldn't bring anything truly hazardous back here. And so even when we're talking about sample return from a place like the moon or Mars, we actually have a lot of different protections in place such that if there is something dangerous potentially in that sample that we don't, you've all seen those sci-fi movies where some alien virus comes and infects us all and turns us all into alien zombies or whatever. So we would be very critical or very careful with how we would treat and handle those samples to protect them and us from them, um,
right,
if we were to bring them back. Now, if we were to find life somewhere else, uh, I think, first of all, we would want to say, are we sure? And so, depending on how we detected that life, if we just saw, for example, some biomolecules, but we didn't find like the actual cell, we would want to study the crap out of those biomolecules and be like, okay, what kind of metabolism does this organism have? Do we get anything like DNA? Does it have DNA? Does it have something where we could figure out like what its building blocks are? We'd
right,
certainly want to send a follow-on mission. Now, if we found like a cell or something like that, we would want to study that, preferably without harming it, but sometimes to make cake. So there are some instruments that we're working on now that are microscopes that would take a sample in and look at it. And currently, I'd have to go back and look. I'm not sure if those. I don't think those samples we could like put them back to sort of like catch and release. I think we would keep it and
right,
look at it until it wasn't moving anymore. Um, but that's something that we should consider, because what if that was the one cell remaining in that whole ocean, right? Chances are probably not, but it could be. And so we need to be very careful. I would envision, if we do find a community existing, an entirely independent ecosystem in one of these worlds, that we would want to preserve that so that we could understand it. Did it originate here on Earth too? The planets have kind of been swapping spit for the last few billion years. Did it come from us? Did we come from it? Or is it a completely separate genesis of life? And what does that mean for the chances of us finding life somewhere else in the universe? So those are the
right.
kinds of questions we would want to ask next.
Okay. That is great. Is there anything else you wanted to finish with? Anything you were hoping we were going to ask? Any
I wish
questions you were?
that we could get to all the questions on the right-hand side. Becky, you're amazing. Graham, hi. Julia, hi. Hi, Chimai. I saw her on there too. Um, I think, well, especially in this uncertain time, like we all sort of have a lot of time on our hands, and there are tons of tremendous resources through NASA, through a bunch of online learning tools for you to go out and start to explore more of your digital world, right? if you're not sure what you want to do when you grow up, or if you never want to grow up like me and you just want to keep learning, go out and explore some of those things and take some time to dive into some of those interests that maybe were passing, but you never really had time, felt like you had time to pursue. Because there is a lot of deep knowledge out there, and a bunch of us who now don't have quite as much to do and are happy to spend some time sharing our experiences. So thank you guys so much for tuning in. And Mark, you've been such a pleasure. Thank you for hosting this. And hopefully we can do a few more of these. I might have a couple of friends who might be interested. Graham, who might want to maybe do one of these themselves.
I mean, it's only fair that you would then get to ask questions of Graham while he's on. I mean, that would only seem fair. But no, I'm so glad you took the time. I know this started, we were talking about trying to get you to Chicago for something. Obviously, that type of travel, that type of event is
Sometime in the
changed.
future, when all this blows over.
Suddenly. But this works really well, and I'm glad we're able to. We kept you for over an hour here, so I'm glad you were able to let us do that. And we got to as many questions as we could. I know there's probably some on the side we missed, but we will. I will try to do more of these. I'm certainly, if there's other topics, I'm happy to bring you back. If there's other people you think we should have, I'm certainly entertaining that.
For sure.
People interested in. So so as long as we're in this position where we're not holding big public events to do these types of things, I think this works pretty well. So I'm glad everyone jumped in and brought their questions. Otherwise, I would have been, I wouldn't have filled the hour with questions. I would have been stumped. So I'm glad you, everyone gave me those questions. Thank you so much. And the video, I believe, again, this is the first time I'm using this format, but I believe that this video is going to save and post to the Facebook page, so it can be watched later. I will double check to make sure that happens, but I am under the understanding that that's how it's going to happen. So if you know someone you think would like this or a particular part of this, particular questions, refer them to that Facebook page. It should be there. They should be able to watch it. And if we hold another one of these, however you heard about it this time, whether it was my Facebook page, whether it was Morgan's Twitter, whatever, however you heard about it, if we do more, we're going to hit those same spots. So find us again. And thank you for coming in, and everybody have a good night. Stay safe, stay healthy.
Everyone, wash your hands. Bye. Don't touch your face.
Yeah. Bye-bye, everybody.